Swayam Prabha. Digital India. Educated India.
Yes, sir. We are all ready, sir. We can.
Okay, sure. So, yeah, I hope everyone had a good breakfast. So, we just before we dropped off, right? We discussed about the different AI techniques, right? So now moving on to the we realize that why cybersecurity is important, right? Now we would focus on what are the traditional cybersecurity approaches, right? Now, why, I mean, we are just now going to that direction, trying to understand that why do we need artificial intelligence in cybersecurity, right? Now, before that, let's understand that what are the traditional cybersecurity approaches we have, right, today. So the first is the signature-based detection, which we have, right? So what I mean by signature-based detection, have you heard about YARA rules? I mean, even if you have not heard, I'm sure many of you would have at least visited the Virus Total website. So Virus Total website is nothing but it basically tells you the different malwares or the different threats which are appearing in different samples, right? Now, these threats appear in different samples in the form of files or any medium it can come through, right? Or maybe the malware can be hidden on the websites, right? So in a traditional cybersecurity approach, what signature-based detection does is basically in an intrusion prevention system. So they are nothing but basically works on the application layer, right? Now, uh, in our OSI layer model, everyone you would be aware of the layer 4 which is called transport layer, right? Which is basically TCP and UDP, right? There are several ports, source IP, destination IP address, on which the connection gets established, correct? Now, similarly, on an application layer, there's no concept of IP address because that is taken care by the layer 4. So on layer 7, basically, most of the detection happens at the application layer. Now, when I say application layers, let's say you have an HTTP request going on. So at there you have a GET request which is being sent. Now, as part of the GET request, there's a GET header, and there are different HTTP headers which are part of that. Like if you have a GET request, there would be a specific header number, numeric value which would be assigned to it. Similarly, if you have a response, you have a 200 OK response, which means the response went through successfully. So all that application, all the signature-based detection works on the application layer data, like what kind of data is being transferred as part of the different applications. Like in this case, it's HTTP. Tomorrow it can be some other protocol like Quick, right? So it basically looks for the data patterns in that, which is obviously, if you would have seen, all the data is in hexadecimal. So it looks for the patterns for that data and then builds a regex on top of that, right? That's what we say a signature-based detection. So say, for example, a GET request is supposed to have a pattern of say A at the start, right? But if it sees a pattern which is B, it then flags an alert. So that is what we call signature-based detection mechanism. Now, the reason it is not trustworthy going forward is because now there are malware, because there are attackers who are also becoming smart, right? They know what are the intrusion detection mechanism or prevention mechanism which is available in your network. So in order to basically bypass that, right? And the attackers also keep on learning new techniques, right? So what they can do is they can use AAAA as the initial mechanism, but in between the payload, they would apply some malwares, right? So as part of a signature-based detection mechanism, it would feel that, okay, it's a valid packet, but it does not look at the entire payload. It just looks at the part of the payload and decides that, okay, this is a valid payload and should be, allowed in the network. So that is one problem. The other is most of the traditional cybersecurity approaches were reactive, right? Now, when I say reactive, is like the problem happened, post that you do the analysis, and then you refine your defense mechanisms, right? So if I have to give you an example, it's like, let's say there is a terrorist who is trying to, barge into your country and create havoc, right? So as part of a reactive defense, what would happen is the terrorist enters your territory, enters your border, reaches the in destination network or the location where they want to create an havoc or create an attack, and that's where you block them, right? You realize that okay, the terrorists have now entered your territory. Now you refine your defense mechanism, make sure that the impact is as minimum as possible. So that is another problem, reactive defense. The third is, as I said, that manual analysis and response. So all this cybersecurity approaches, right? And all the organizations have a threat intel team which works at the back end, which looks at different samples which are available on the internet, right? Different samples in the form of what are the different file hashes which are getting transferred over the internet, and it looks at that and then basically does a manual analysis and then builds the regex out of it. Then it basically, so all whenever a sample is given to you, right, as part of a researcher, there are two things you would do. You try to understand what that sample is doing, and then write basically a regex based rule, and which would detect this, that this sample is being sent, right? If it is malicious, you want to make sure that before it penetrates the network, it should be detected as soon as possible, right? So that is another problem. Again, I won't consider manual analysis. The reason I put here is because just to make you understand that how the threat intel works at the back end. Even with AI in cybersecurity, you would still need those manual analysis, right? Because there would be new samples which would be coming in. Your machine, the algorithms which you have built as part of the automation or as part of the AI, is not going to detect the new threats which are coming in, right? You need some kind of intelligence. You need some kind of manual intervention to understand that okay, is this the algorithm detecting correctly or not? So that always goes hand in hand. So your manual analysis is not always going to go 100% off, but maybe as I said, that the example which I gave you, right? The code which I had to write in 7 days, which we decided to write in 7 days, was done in one day, right? So that we can put our 6 days efforts in something else. That's how this would go, right? Let's say if a threat researcher was analyzing, say, 100 samples on a given day, now he would analyze, say, 40 samples, 50 samples, but he would try to do something different than what the AI is giving to it, right? So that's how the productivity would also increase. The other is in my traditional approach, you don't have contextual understanding, right? You always think from a network perspective that this traffic entered my network, that's it. It tried to access some applications, and maybe one application went down, two application went down, three application that went down, right? But you never build that contextual understanding. You never build that relationship, that how did that application service went down? What was a trigger? What was the entry point? What was the exit point, right? So basically you don't have the visibility. Like I mentioned, right? The terrorists entered your territory, but you don't have the visibility from how did they enter? How did they enter the border? Obviously, as part of a reactive approach, you always look back and look at trace their entry point, right? But if you had a visibility from the start that, hey, someone is entering, they would have alerted, so that rather than entering the territory, you would have blocked them close to the border rather than, penetrating them inside your territory and creating and allowing them to create those havoc. And the last is, as I mentioned, right, limited visibility with traditional approaches, because when you look at the cybersecurity, right, there's so many point products which does some function of it, right? I'm not going in depth on that, but just to give you an example, right? Every day, when you enter your college, right, you have your I card. Obviously, you don't want to swipe somewhere, but some you have the security card where you enter your registry, right? So there is always a constant visibility, that who's entering, who is going out, right? But let's say tomorrow I am a faculty, right? I am from Cisco, and let's say I happen to visit your organization, or sorry, your college, right? What I would be given is a temporary gate pass, and the security guard says that, hey, this is a building where you want to go, and this is a classroom where you want to, where you are supposed to deliver the lecture, right? But which means the security guard is assuming that I am going to go to only that dedicated classroom. But what if I have malicious motives? Again, I don't have, but just for example, what if I'm not going to that classroom? I want to just look at the entire campus. There's no one who is looking at me, right? The reason is being there is a gate pass which has been issued to me. Yes, there are CCTV cameras, but there's no one who is going to stop me that, hey, you are supposed, or there's no one who is authorizing it that you are supposed to go to classroom A, but you're roaming around to different buildings or different campuses, which you're not supposed to, right? So that is another problem. You need to make sure that if a person, a third party person, is supposed to enter the classroom and leave the classroom. That's it. He finishes work, leaves the classroom, goes to his home. You don't want him to roam around different campuses, even though I am from Cisco, but there's several compliance checks or the security checks which you want to do, which is being lagged by the current cybersecurity approach. Does it make sense? Okay. So that brings us to what are the applications of artificial intelligence in cybersecurity, right? As I mentioned, the first is threat detection and prevention, right? We would look into one real use case which happened actually to Cisco. Uh, and how did we prevent it? I'm sure you would be aware of that, but again, even if not, we would just I would walk you through that. But the first application is a threat detection prevention, right? And more importantly, not having a reactive approach, but having a predictive approach, right? That before a threat is supposed to happen, you are basically alerting all the network admins or all the appropriate authors or the appropriate whoever has the responsibility of securing your network. You're basically alerting them that, hey, there's something malicious is going to happen or is about to happen. Make sure you do this thing, right? So that is a predictive approach, which where AI can help. The second is anomaly detection, right? As I mentioned, anomaly detection is like, say for example, let's say there is a user, like you log in. Let's say you log in daily to your organize or your college network, and let's say your daily task is to download, right? Let's say your daily task, you have, let's say there's an application where you can download your accounts, just for example, right? And as a normal user, what you do, you generally download your academics, right? Or maybe you download academics of your best friend, right? But what if you try to download academics of past 10 year students, and also get also download their personal details which are being stored in the college website? Again, assuming that you're able to hack it, you're able to get details which you're not supposed to. That is where an admin can be alerted, right? That, hey, this user is something doing abnormal, which he's not supposed to do. And if he's doing, how do you detect it? How do you block it then and there, and not wait for them to download all bunch of data, create those damage, and then you alert the network admin, right? It is more about doing at the same time when the attack is happening, right? The third is user behavior analysis. As I mentioned, the example which I gave, right? If I enter your campus, right? And if I'm supposed to enter classroom A, right? As per the gate pass which has been issued. Now, if I roam around the entire building, that is not how I'm supposed to behave, right? I'm supposed to go to a specific classroom, deliver my lecture, and get out, right? But that is not what I'm doing, which means there should be someone who should be alerting the security guards that, hey, the person whom you have entered seems to be roaming around. Just make sure that you um, uh, alert him, not alert him, just drag him and say that, hey, you are not allowed to roam around. Just go back to the classroom where you're supposed to deliver the lecture, right? The fourth is malware detection. As I mentioned, that what if, as a professor, I bring a USB stick, right? And I enter into your network laptop, right? Which has a malware in it. Now, as an cybersecurity, or in order to provide security, you need to make sure that the two things, right? The malware should not be downloaded. First of all, the USB should not be detected, right? If it is an external USB stick, and even though it's and more important, it's a personal USB stick from which I have brought, right? So it should be detecting that. It should not be allowing it to, I mean, it should, the endpoint or the laptop where I'm inserting, it should not be detecting the USB stick for the first thing, right? Now, let's say it allows a USB to be inserted. The second stuff is it should not allow the malware payload to be downloaded on the endpoint system, right? And the way you do it is basically you have different agents installed on your endpoints or your organizations or on your university endpoint systems, which are governed by them. You have different agents which detects this, which detects that if there is an external USB stick, block it there and then, right? And the fifth most important is the incident response and investigation. Whatever we talked about, the 4 points, right? Threat detection, visibility. The last thing is, what do you do once you detect something is maliciously happening, right? That's where the incident response and investigation comes in play. That you detect something, you are being alerted. Now you need to restrict it then and then, right? As I mentioned, that if there's a USB stick which has been detected, make sure the payload is not downloaded. Even if the payload gets downloaded, you make sure that the endpoint PC is not able to communicate to different pieces in the same network, right? Because it would try to infect other machines and it would create a havoc in your network, right? So these are the different applications which is where AI can come and play, right? Any questions here? Okay. So this is one of the secure AI framework which Google has given as part of its AI platform, which with the name called Chronicle, right? So Chronicle is the AI framework which is being built by Google, and basically it is for professional use, obviously, and they sell it to enterprise network. So these are the 6 points which Google came up with. Again, this is not the standard, but I just wanted to highlight that, okay, these are the common pillars across which all the any organization which builds its AI product would be based on. So the first is expand the strong security foundation to AI ecosystem, right? What does it mean? So you would have came to know that artificial intelligence does not work on its own, right? You need to input something. So when we saw it chat GPT, or when we saw it the search engine, you input something, right? There's no magic which is happening where the machine would just give you some vague responses, right? It needs some input and it would give you an output. Similarly, when you talk about AI in cybersecurity, the input which you get is the different security solutions which you have deployed around it, right? So say, for example, the simplest example which I would give you is your university campus would be having CCTV cameras, right? All those CCTV cameras, what do? They capture the feed, and there's a centralized server where you can view it, right? A particular network admin can view it, right? Now, what it would do is it would feed that data to an AI system, which would look at the patterns and the time intervals, the particular location at which, what are the probabilities of different persons visiting that site, right? So today it's a student, tomorrow it's a lecturer, day after tomorrow is some scientist, right? But what if there's some other person who is visiting that site, right? And it has never seen before, right? So what it does is as part of the data which is being fed to the AI system, it would alert the network admin that, hey, even though you have CCTV cameras, even though it is capturing what it's supposed to, I feel there's some not malicious, but there's some abnormality which I'm viewing it, where there's some a person which has not entered the university till date is being seen here at this particular location, which ideally we have never seen before. So would you like to have a look, right? So that is what it says, right? So you need to have the existing security solution data should be fed to the AI ecosystem, and then it basically builds the patterns, and then alerts you accordingly, right? That's what we say, extend detection response to bring AI into the threat universe, right? So each of the organizations, right? All the organizations, like when we say Google or say Cisco or different vendors, right? All the OEM vendors have its dedicated threat research team. So what does it do is basically it looks for all the samples which are available on the internet. It tries to build a pattern and then alerts you that, hey, if you see this file sample, if you see this hash value, it looks to be malicious, right? So the existing security solutions which are there should be integrated to the AI, and also you bring AI to the threat, your threat intel platform that basically collects all this data. It collects the data from the internet. It collects the data from your network and then alerts you the different threads, the new threads which are coming in, so that if you see the same thread in your network, right, in your organization, you are alerted before it is being attacked, right? And as I said, that you need to automate the defenses, right? Because now, as we see in the later slides, the attacker can penetrate your network not from the front gate of your university or not from the back gate of the university, but it can penetrate from any gates, right? Maybe it can climb your wall, right? Which is practically impossible. But just to create an analogy, when I say climb the wall, basically, if you have any resources which are available on the internet, it can attack it using different attack methodologies, right? So you need to make sure that you automate those defenses, alert the network admins, and create those templates that what needs to be done if this particular attack happens, right? And you need to have consistency across different control frameworks which you have deployed for your AI for risk mitigation, right? When I say consistency, you create different templates as per you, right? That if you see that there is a, like I mentioned, that if you see a difference in pattern, if you see a particular visitor who is not supposed to visit a particular building, what you do, right? So you create those consistency rules across all and feed it to the AI systems, and you adjust the mitigations and create faster feedback loops, right? As I mentioned that AI, there would be a possibility that AI can generate a false alert. So that's where the feedback loop is important, where you, as a network admin, you say to the AI that, hey, the alert which you generated was not correct. And this is where you need to improve, right? That's what ChatGPT also did. And you also need to have automatic checks to validate the AI performance, right? So you basically look at the set of actions which was taken by artificial intelligence tool, and then you compare it with the manual approach, what you would have taken, right? And if there is any deviation, you always give the feedback so that your AI system gets refined. Okay. So this is what I'm sure you would have seen a specific IT network, right? So let's say on the left side, there are users who are in your university who are trying to access different applications over the internet, right? And that's what you see on the cloud. And there is a perimeter security firewall, and all the traffic towards the internet gets inspected by the security firewall, and then it is forwarded to the applications which are hosted over the internet, right? Now, this was a traditional IT landscape. Now, why I say traditional? Before COVID, right? Before 2020, everyone, I mean, obviously, you did not had a choice. You always had to come to university. Obviously, during COVID, there were remote lectures, but even in a professional world, everyone was working from office. There was no such concept of working from home. Obviously, maybe in 1 or 2 odd days you would work from home, but generally you used to work from office, which means that you knew that from where the traffic was getting originated from, right? You always knew what was the entry point, what was your exit point. That's why your security, right? And the kind of applications which are hosted on the internet were limited, so you knew where to deploy a security solution. It was more, the scope was limited. But with the onset of COVID, with the kind of applications which are moving towards the cloud, the perimeter is no longer restricted. The scope has just expanded. That's what you see on the right side, right? There's so many application devices. Like as an individual, you would be carrying, say, 4 devices, be it your smartphone, be it your smartwatch, be it your laptop, be it your iPad, right? You have so many so many devices, right? Because and the reason because for that is now you have internet, you can access internet, you can access any information from anywhere, right? Which means your traditional parameter security, which was where the scope was limited, now it has expanded, right? And that's where I talk about this, right? Defense in depth. So pre-COVID or before COVID, right? Where the everyone was working from office, we had this defense in depth mindset, right? So let's consider this palace, which is your university. And I always knew that there was the scope was always limited. Like any visitor would be coming from the front gate, and they won't be climbing the outer walls, and I would all have all my security solutions at the entry point, right? Or maybe at the exit point. But with the onset of COVID and with the applications moving towards the internet, now you can see that the attacker, there's no longer restricted access, right? He can climb the wall, or he can have the visibility of what is hosted at the building, which is at the back, right? Which is highlighted here, right? Rather than coming from the front gate, he can enter from the back gate, not physically, but over the internet, right? Because eventually it would try to exploit the resources which are hosted, or the different applications which are hosted over the internet, right? That's why the traditional or the defense in depth approach no longer applies here. And you need to have a constant visibility. You need to have different AI mechanisms, because there are so many users who would be accessing your data. You need to have some automation there to understand that, okay, who is accessing what, and is he authorized to access that or not, right? So that brings us to a zero trust architecture. I know when we talk about AI in cybersecurity, right? All those principle also gets applied here. So uh, have you heard about the zero trust architecture, which was coined by Gartner? So Gartner is nothing but an institution which every year comes up with different security frameworks which all organizations should align to. So in this case, zero trust. So what zero trust means is never trust anyone. Okay. So what it says is never trust anyone, always verify, right? Which means that the example which I gave you, right? As a lecturer, say I'm entering your university campus, and if I'm supposed to enter campus A or building A, there should not be an implicit trust on me that I would only be visiting that building. I am free. There should not be implied trust on me, and also should not be assumed that I would just be visiting that campus. As I mentioned, that I might be possible that I would be roaming around in the building, right? So that's where the zero trust concept comes from. It was always there before also, but with this onset of different applications which are coming in, that's when now more importance is given to zero trust, which says that never trust and always verify. And these are the pillars, right? Where the zero trust mechanism should be applied. One is the identity, as I mentioned, that are you the user? Are you the user authorized to access this, right? Let's say, for example, if I am a student of a university, I should be having access to all the rooms in the campus. Whereas if I'm a lecturer, I should only be having limited access to the campus building. Similarly, the devices which you bring, the mobile phones or the smartwatches which you bring to your university campus, are they aligned? Do they have the most recent version downloaded of the operating system? Are they having any malwares installed in their mobile phone? So all that posture check you need to make sure is being done, right? Then the network, right? You need to make sure that the network through which they are accessing the different data is secure. And if it is being attacked, you make sure that there are appropriate defenses in place to make sure the attack is never expanded on a larger scale. And as I mentioned, that there are different workloads which gets deployed either on the cloud or on your on-prem network. They need to make sure that those workloads are protected, right? Be it on the cloud or be it on the prem, and the data which gets transferred on as part of this applications, you need to make sure that the data is secure. As we saw in previous slides, if the data gets leaked, it's a privacy. The privacy data, if it gets leaked, it can cause multiple, repercussions on the end users health, or on the personal data, which can cause financial impacts, right? And last but not the least, you need to have visibility, end-to-end visibility of what is happening in your network, right? As I mentioned, that if there is a terrorist who is entering from the border, you need to have a visibility from there and there, that okay, there's someone trying to enter my border, I need to restrict them there and there, right? Rather than allowing them to enter my territory. So all the principles of this AI gets aligned to zero trust, and then you build the security solutions around it, right? Okay, so coming up with this example, right? So I already gave you the hint. So this attack actually happened to Cisco, right? I think 2021 during COVID, right? And it just tells you that I mean, an organization like Cisco can also be duped, right? And in this case, yeah. So in this case, basically, you can see that what happened was, there was this employee like me, right? Uh, you was syncing his password to a Gmail, right? We all have this browsers, right? On the browser, on the Chrome browser, you have this option of syncing everything, syncing all your data to a Google repository, right? In this case, the user like me, who was a Cisco employee, sync the password on the Gmail, right? Sync password means it syncs password to all the user websites which you're doing, right? Which also includes your corporate websites where you're entering your corporate username and password, right? So as part of a university student, you would be having your username and password to log into your portal, right? Similarly, all employees in Cisco have their own username and password, right? Which is tagged to my identity, where I can use it to view my pay slips, which I can view to use my grades or promotion cycles, right? So, and also different applications which only I can access, right? So, though he was syncing that password, right? Now, what happened was his Gmail account got compromised, right? Maybe the Gmail credentials were exposed to dark web, and this attacker basically purchased it from dark web and got his username and password, the corporate username and password, right? Now, what he did was, once he got that, now he tried to open a particular Cisco website, right? So we, as part of an organization, we have internal websites, right? Now, let's say in this case, he tried to open an application where where internal data of Cisco is available, right? He opened that. Now, as part of a zero trust, all our applications require dual factor authentication, right? Even Gmail nowadays requires dual factor authentication if it detects you're trying to log in from different location, right? It asks you to enter a numeric code. Unless and until you don't do it, it does not take you forward, right? Similarly, in this case, he tried to open that application, now which triggered a MFA, dual factor authentication. Now in dual factor authentication, if you know, what happens is, the numeric code is being sent to an authenticator device. What is an authenticator device? It's a device which can be a mobile phone on which that application is being installed, right? So that numeric code would be visible on that. And once you enter that numeric code, so basically the way it happens is, let's say you are opening google.com, right? What it does is google.com forwards a request to a two-factor authenticator. It can be, there are different OEMs which provide that, right? So it redirects a request to that. You see a 4-digit code on your laptop screen, and you need to enter the 4-digit code on your authenticator device, which is your mobile phone. And if that gets validated, you're allowed to access that application. Clear? Now, in this case, the attacker did the same thing. He opened the application. And what was happening is, initially, before this attack, the way it used to happen was, the moment you open the application, it used to trigger a dual factor authentication, where it won't show you the 4-digit code on your screen, right? What it used to do is it would just send the dual factor authentication on your authenticator device, and you just need to approve it, right? And there was only a tick or cross, right? So in this case, um, the attacker did that, right? He opened that application, it triggered a dual factor authentication on the authenticator device of that employee, right? Now, the employee, in this case, he did a MFA fatigue. Now, what do you mean by MFA fatigue? Imagine uh, someone is calling you, say, at in 1 minute, you are getting one call, right? So you'd receive, you'd speak to him, all done. But let's assume that in 1 minute you're receiving 1,000 calls, right? Repeatedly, right? You got one call, second call, third call. So at the best, what you do, either reject or accept, right? Similarly, in this case, he got 1,000 or 1,500 requests at one go, right? Now, maybe he was in some meeting or whatever, right? He just clicked on accept on one of them, right? The moment he clicked on accept on that, the remote attacker got the access of the Cisco network, right? Because um, uh, he had a VPN access. I'm sure you would be knowing about VPN, right? VPN is something you connect to VPN, you can access private resources. In this case, he got access to that VPN because he had the access to credentials, and now he had the MFA authorization was also successful. The moment he got that, what he did was he tried to he implanted, or from his endpoint machine, he downloaded some malicious scripts on the user endpoint on the corporate laptop, and from there he started traversing different application servers in the same network. Maybe he ran different Nmap tools to understand what are the different services running on different application servers. And once he realized there were critical database servers, he tried to do lateral attacks on that, right? But luckily, we had defense in we had different agents which were installed on those application servers. And the moment there was some anomaly detected, this user was put in an isolated VLAN. What do I mean by isolated VLAN means? There was literally no access to the network where the attacker can do lateral attacks, right? So basically from that endpoint machine, all the remote machines were unreachable once it was being detected. And because of this different endpoints installed, what we covered before, right? That, okay, if the attack happens, you should be faster enough to detect it and prevent it. And that's what we did. And in this case, we were lucky enough because of the in-depth security mechanism which we had on our endpoints on our network. The attack was not the attacker was not able to extract any critical data, and more importantly, it was not able to affect any other critical application service, right? But this was a learning for us. That the So what were the learnings here is, as you can see, that the first thing is, yes, from a user perspective, you should not be syncing the password, right? And that's a learning for us also, that I mean, post this, I have stopped syncing my passwords through Gmail, and I believe you should also be doing the same. That's first. But the most important thing is the dual factor authentication which we had, right? One of the flaw in that was, as I mentioned, was when you used to open any application, there was never a 4-digit code which used to appear on the laptop screen, right? Which means that as a part of a authenticator, when the MFA request used to come to me, there was always a checkbox, there was always a accept or reject, right? I never had a context of who initiated this application, what was the application for which this MFA request was being raised. Suppose this, we made changes that now we have a 4-digit code which appears on the laptop screen. Now how does it help, right? So imagine in this case, the attacker opened some application, some Cisco website. There is a 4-digit code which appears on his screen, right? Now, the same 4-digit code needs to be entered on the authenticator device. Now, the authenticator device is something the employee would be having, right? The attacker won't be having the visibility that whether he's entering the attacker won't have visibility of authenticator device, similarly, the employee won't have the visibility of the 4-digit code which is being seen on the attacker machine. Getting it, right? It's something like, let's say you have your colleague's phone, right? And your colleague's phone, uh, we have this 4-digit code um, lock, the screen lock which we have, right? Which only your colleague can open. You cannot open, right? Yeah, obviously, if you know that code, that is a different thing. But let's say if you want to hack into his system, into his phone, you need to know that 4-digit code. Similarly, in this case, the attacker knows what is a 4-digit code appearing on his screen, but he cannot enter it because the authenticator device is with the employee, right? So that was one way where this fatigue attack was being prevented, because the authenticator device needs to validate what is a 4-digit code, and the employee does not know what is that 4-digit code because that application, that request was never launched by him, right? So that is the way, that was one of the improvement which we did as part of our dual factor authentication. And I would show you this. Yeah. So as you can see, this particular is a duo mechanism, the fingerprint icon which you see here. So that was one improvement which we did. The other improvement which we did, right? We always do the posture check on the source machine who is initiating the request. Now, what do you do on the posture check? You basically look at the health of the endpoint, whether there is any malicious script which is being installed on that endpoint. Are there any security settings which has been disabled on that endpoint? And if you detect something like that, he would it would basically restrict that user from accessing that application and would give you a prompt that, hey, it seems that your security score is very less of your endpoint. Please fix this before you can access these applications. So those were the two improvements which we did. And as I mentioned that even if the when the attack was happening, the reason it was not able to perform lateral attacks was there were different EDR agents. EDR is nothing but endpoint detection response agents which were installed on the application service, which prevented the attack from uh, blocked the attack, or which prevented the attack from happening to different critical application servers, right? So EDR we always had, but this was the improvement which we did on dual factor authentication, right? So this basically tells you that how it is important to have different security mechanisms in play, right? And now you would realize that, or you would ask this question, that where would AI fit in this, right? Now, the way AI would fit here is basically there are different, it would look at the different behaviors of what did the attacker did when it penetrated the Cisco network. And depending on the kind of actions he did, it would create an algorithm around it, and would say that if in future those similar commands are being entered, which means there's some attack which is happening, we need to alert the network admin, and also at the same time give him the set of guidelines how to prevent those attacks from happening, right? So this was something which happened in our case, and when this attack happened, in next 12 hours we had to reset our passwords, I mean twice or thrice, right? So that is the way, I mean, that was something, a predictive prevention which we did, where we saw that there was an attack happened. Now, to make sure that the attack does not gets repeated to other employers, we were asked to reset our passwords, right? So that's how it happened in this case, and this is a valid use case, right? It can happen to anyone, right? Okay, so that brings us to the end. So go back to the menti.cisco.com, this one. And there are several questions. Okay. Yeah. So go back to this. Yeah, go back to this menti.com. There are a few questions. I would like you to answer the same code. Yeah. So yeah, I could see few answers coming in. So can you please answer yourself? Perfect. Someone is saying OpenAI, someone is saying Bard. Oh, okay. And this is while I was discussing the session, I gave the answer somewhere. So if you're listening carefully, you would be getting that. Oh, there's someone who is saying ChatGPT. Nice. Okay. Is that the one? I think there are more than 15, right? Okay. So yeah, most of them got it correct. So it's Bard. It's not OpenAI. So OpenAI is from Microsoft and the founders of OpenAI, I think Tesla Motors. But yeah, the Google came up with its own model, Bard, and OpenAI is itself ChatGPT, right? And Bing is from Microsoft, where they're integrating Bing with ChatGPT. Okay. So Bard is correct. Perfect. Next, what are different pillars of zero trust? So we discussed this at it was at the last few slides of our session. So what are the different pillars of zero trust? Is it endpoint, wireless, application and data security, or orchestration? Okay, someone is saying endpoint. Someone is saying application and data security. Okay, so I think most of them got it correct. Yes, it's application and data security. The other pillars is identity, network security, and data. Yes, that's correct. And the last, how does AI help in threat prevention? Is it reactive approach, defense in depth, predictive approach, or faster response? Hmm. Okay, so someone said predictive, someone is saying defense in depth, someone is saying reactive. Hmm. Yeah, so most of them are saying defense in depth. Okay, someone is saying predictive. Okay, so I believe this was a bit tricky one. Uh, yeah, I mean, those who have answered defense in depth, yes, AI helps you in giving you a defense in depth, but if you understand the palace analogy which I gave, right? That defense in depth is about the scope is limited, where you know who is your entry point, who is your exit point, right? But where does AI help in is since now the perimeter is thinner, is no longer uh, stitched to the enterprise network. It's now basically the network is everywhere, right? Which means the way AI can help you in threat prevention is by a predictive approach, right? Because defense in depth was always reactive, right? That along with the limit, along with the scope was limited, you always, the attacks were always used to happen, and then you used to build your defenses around around it, right? But AI, the reason it helps is more predictive, right? Before the threat is going to happen, it gives you that edge that, hey, there's something which is going to happen bad, do this so that it's the attack does not expand to other network, right? And as I mentioned, reactive approach is more a traditional approach which we used to take, but now it is moving. The needle is moving towards a predictive, and that's where the AI helps. So yeah, I mean, this was a pretty tricky one, but yeah, predictive approach is the right answer, right? Okay, so I think that's it from my side.